Hello, students. Today we are continuing with data capture. Uh, Last week we've been talking about some theoretical aspect behind data capture. I've mentioned API. I've been talking about web scraping and so on. So today we'll basically be uh, talking about how to fetch data, more specifically from the World Bank API and the NASA API. I'll talk about that later anyway. And you are going to learn how to import these data in R using your API. And also, I'm going to give you an idea about the Pocket file, how to write and read, how to create one and how to read one. Also, by the way, I forgot to mention, I will explain to you what an API URL is, as I just said here. I'll explain to you what an API URL is, how you can fetch data from World Bank, for example, from open source platforms. Okay. Having done this, then I will move on to how to store your data in MySQL, how to store your data in a database using MySQL, and also applying some basic SQL statements. To start with, what I want to do right now is to discuss this concept of an API URL. Okay, we'll start by turning in a single web address. Okay, a single web address. Here we'll start by the World Bank API URL, which is quite well known. What we are going to do is that we are going to turn that into a clean data set. We are going to turn that into a clean data set. We are going to do a chart with that and also draw some insights in R. That's basically what I'm going to do right now. Um, First of all, when I'm referring to an API URL, let's just make a quick reminder of what an API is about. When I'm talking about an API, I'm talking about an application programming interface. That's what we refer to as an API. Basically, the idea of an API is just like a polite way for a computer to ask another computer for data. That's basically what it is. It's like one computer is asking another computer data. So let's just make the distinction here. We are not scrapping a web page. We are making a clean documented request and getting a predicted response from that request. You also need to understand what the URL means. Now, when we are referring to the URL, it tells the whole story about this data set that we have. Okay, there are three parts to a URL. Number one, let me just copy and paste the URL down there, and then I will talk about that in a moment. Don't worry. This is an example of a URL that we have for the World Bank API. Now, when you look at the URL, there are three main parts in that URL. Number one, there is the base, there is a path, and there is a query. When we talk about the base, we are talking about the site that we are asking information. We're asking information or data. When we talk, for example, in our case, you will see that this, what I've just highlighted, represent the base of that URL. But then on the other hand, there is also the path. What is the path? Which data set we want. Because, for example, in the World Bank, you have several data sets. But what we are interested in this example, in this lecture today, we will be interested in the total population for the island of Mauritius. All right. So then you need to include in that URL, in addition to the base, the path. The path, for example, is here before the question mark that you see here. All right, if you want to take the question mark, whatever, but just everything that comes before that question mark becomes basically your path. And this indicates what data set you've got. And then you have the query. The query basically is the extra options. The extra options like the format, as you would see in the URL, and the date range as an example. All right. So you will see that you inform additional parameters, you give additional information with regards to what you want from the API. Basically, you want also the um, data to be JSON. You want the number of per page. You want per page to be 200. The higher this value, the more information you will obtain in an HTML page. All right. The lower this value, obviously, the smaller the number of information you will have in a web page, and then it will be um, divided. Your screen will be divided into several pages depending on what you have. For example, if you have a small per page, right, like 20, you will have very few information in your JSON file, and then you will need to click on another page to be able to see additional information. But when you put it as a big value, you may have to play with that value if you don't have the information that you need in that single web page where you have your JSON file. Then you need to play with that value, and then you have the date as well. So all these are what consist of a URL. You have the base, the path, and the query. You will see that I've given you an interactive display. Let me just find this out. An interactive display where you will be able to get more information. You can play with that interactive display, and you will see how the URL change accordingly. All right. So, for example, for the World Bank API, you will see you can play with that display. For example, if you want United States, you will see that this will change. It will become US. The rest stays the same. If you want something else from the World Bank, you might use another indicator, as you see here, and so on and so on. So as I just mentioned here, you have the base, the path, and the query. The same thing applies, obviously, to the NASA data and any other open source data where you have the ability of using an API. All right. So you can play around with that. If you want some additional data or any other data, you can play around and just find out if this works. uh, I'll just take the example of the World Bank API. Let me just go back to Mauritius and go back to what I'm going to work with today for the population total. And then you will see that this has changed. You can just copy that and paste it in your browser. As far as possible, if you can do it in Firefox as well, you can do it. It would be good. Here we go. You will see that it has loaded the JSON file. And the JSON file, if you want, you can click on Pretty Print. You will see that it contains all the information, the metadata, and then the nested objects. As you will see here, there are nested objects. This include this object includes the indicator, the country, and so on. And the country itself, it is it contains another nested object, which is the ID and the value, and so on and so on. So the indicator ID and the indicator value, all these are the different information that you have. So you can play around with that URL to know how it works. You will see that I've also given you some official API documentation that you can go through for these particular websites. So you can just have a look afterward. I'm going to leave that to you. But normally, you will see that here I'm giving you a list of URLs. You might ask yourself, how do we get these URLs normally? How can I imagine that this is like that? How can I imagine that I should write country slash mu indicator and so on? Of course, there is no magic behind. So there is logically a way of going about it. It's about just basically Googling. You need to Google these information to be able to know what URL you have to use. Let's give this a try. So we go on Google. Sorry, we go on Google. When we go on Google, what we want to do now is to type something like um, World Bank Indicator API or something like that. Okay, whatever you wish to call it, you can just type World Bank Indicator API. When this is done, then you will go about the indicators API documentation, for example. And there you go. From this example, you can already start guessing what is a path, the what is sorry the base, what is a path, and what is a query there. Okay, you can already get an idea. So number one, you will see that here itself, we already know that, for example, this part here, excuse me, this part here up to V2 represent our base. All right, excuse me, I can't get this correctly done, but highlighted, but at least you understand that what I'm referring here, that this first part represents the base and the rest become basically your path. And then after the path, there are additional things that you can include, which are your API queries, as I mentioned to you earlier. How do I know this is a base? Obviously, if you click on basic call structure, you will get some additional information pertaining to examples of APIs. All right. And if you go down there, you will see that, for example, if you carry on, each time you are seeing country, but the the one that stays the same, irrespective of what you are using, irrespective of what you're using, is going to be the base. For example, here you see that there is country, but not always do we have an API related to a country. For example, you will see here languages, you see. So if it is language, then what does it mean if it is languages? It means that you don't have a country here, but the base stays as it is. So you can mentally split that base, that URL, into a base yourself just by having a look and documenting yourself on these website, for example, to get some additional information pertaining to the API. So let's get back to the previous example I was talking about. For us, we are going to use population total. How do I know now that this is supposed to be population total and so on? Okay, how do I know that? Uh, of course, to be able to know that, I will need to go to the World Bank Indicator Catalog. All right. From the World Bank Indicator Catalog, I'll be able to guess a little bit what are the indicators that we have. All right. So let me just maybe Google something else. World Bank Indicator Indicator Catalog. If I go to World Bank indicators uh, catalog, let's go there. Indicators data. This is development indicators, but let's click on the indicators, which is general here. Click on that and we wait for a moment. That by the time that this open, now the web page is open. We have the different indicators. How would I know what indicators I need to use? Of course, I need total population, but I do not necessarily need to know that this should be SP pop total or whatever it is. So when I just come here and in the quick search, I can just type population total, for example, right? Population total. And then when I type population total, I can click on one of these and I will see that the total population is related to that indicator as you see the web browser bar. The web browser bar. So that's a little bit how you get an idea of what you need to type in there in the generate in the URL. You will need to get this information, for example, about the base from the web page. You will get also the information about the path when it comes to the indicator from the obviously from what I just showed you here. And then you can add additional queries, as I mentioned to you, in your URL through these question mark. And I just give you an example earlier for this question mark. For example, if I change that, change that to, let's suppose 20, let's suppose to, let's not even 20, let's make it 2. Then let's have a look. You will see that now, let's click on pretty print. You will see that there is less information given to you. We'll have page 1, and then it says that there are 8 pages in all, and the per page is 2, and so on. So to avoid having only part of information, you can increase this value if you wish to even 200 or 20. Depends if you don't know the information. Like for example here, 200 is already big enough, so you can play around with these values to get more information on the query. Then you can choose the format of your data, which is JSON in our context. And we have also other information like the date, where you want the date to be. It can be 2010 to 2024. So quickly, just a quick browse through the data. You will see that there are metadata here related to our our uh, data, that JSON file, that data that we obtain. We've got the indicator, and the indicator contains an ID and also a value. All right, the value is population total, and the ID is SP pop total. L. And then you have, uh, so basically you have an object where this object contains indicator, contains country ISO free code, contains date, value, and so on. But the indicator itself contains a nested object, as you are observing here, which contains an ID and a value. And if you go down there, you will see that there is some of information, if I'm not mistaken. Let me just check this out. No, that's okay. So you've got an idea, as I just mentioned to you here. If you want to know how we get to that URL, obviously it involves going on Google and understanding and trying to Google API for World Bank, things like that. And this is where you will get additional information with regards to that. You can do the same thing pertaining to NASA. You can click on the documentation that I gave you, and the documentation will give you more details about how to get data access and so on. All right, how to use the URL. I mean, before I forget, there is something else. What about the? You remember here, you have a country code that is included as well. So how would I know what country code I need to include what is a country code. MRU, MU, MUY, what could it be? The way that you can identify this country code is, again, you will need to go on Google and then you type country API queries World Bank. Country API queries World Bank. And then you will see the country API queries here. You click on that, you will see the country API queries. You click on that. And then to list all countries, you can click on that to get some information. You will see here again that there is some information. You can search for Mauritius. Okay, you control F and then you type Mauritius here, and you see that Mauritius is not there. Obviously, you will see again here there are 6 pages and there are 50 per page. So that's why you're not able to see all the countries' code, including Mauritius. Normally, you will use the ISO code for the different countries. Okay. So let me you're not going to use a country ID when you're defining, you will use a ISO code in our context. So what do we want to do is to increase this number of pages and so on. So to be able to do that, I don't know if you recall, we can add additional information. For example, you can type format is equal to JSON. Just remember that when you have defined your path, you can uh, define also your additional queries like the format, which is JSON per page, etc., date, and so on. But here we don't need date, but we need only the per page, and I put it as 400. You may wish to put it as 500 as well, it doesn't matter. And then the JSON, and we do enter, and then we wait for a moment. Now we'll see it in the JSON format. You can click on pretty print, you'll get information again which is a bit more readable. You can do a control F and then find Mauritius. And then when you search Mauritius, you will see that the ISO code for Mauritius is MU, whereas the ID is MUS. So we are not going to use the ID in the URL when we are building the URL. We are going to rather use the ISO code, which is MU. So I just explained to you how you can find that. Again, it is through Google. All right. That's how we get to determine these ISO code and so on. So you will see that the object here about Mauritius contains all information pertaining to Mauritius, including the longitude and the latitude, by the way, that you will be using, that you can use to find data from NASA. All right, because it will request longitude and latitude. You can find this out from NASA. So, and by the way, it is also part of your assignment that was given to you. You will see that Mauritius is classified as an upper middle income country, and you get all these different information with regards to Mauritius. It is a sub-Saharan African country, excluding high income and so on. So so that's what we have if you want to find the country code. Now that you have understood uh, a little bit about where API links come from, like the URLs come from, we can start working. We can use one API in R, and we will basically, I'll show you how to connect to the World Bank Indicator API. All right, how you can connect to that World Bank Indicator API and download Mauritius population data and turn it into a clean table that we can analyze. So that's basically what I want to do with you. So what we'll do, we'll go step by step. Number one, we will build the URL that is the base path and query parameters. Obviously, this comes from what I just explained to you earlier, but we will need to know what the URL we are looking for is, you can use this interactive display that I gave you to be able to build your URL as you see here, or you can also mentally build it yourself by remembering what the base is and putting the country with its code that you can find out on the API as well. What are the country codes that you can use? And then you can also find the indicator as I explained to you earlier. Now that you have built your URL, that you know how to build your URL, you've understood a little bit about the URL, how to determine how to write it. So the next step is about what? So the next step here is we want to use a function HTTR that will send a request and check that the response, we will get into that anyway in a few minutes, response is valid. Of course, if the response is not valid, we will need to find out whether we have an issue with our URL. Maybe it is wrongly written. Maybe we've done something wrong. We forgot an information in there and so on. Then, but normally, if you've written your URL well, there should be no trouble there. So then the next step is that we will convert the information that we have obtained from the website, convert the JSON file rather, what I mean, into a usable R data frame with a package that we call JSON Lite. That's what I intend to do. Then, when this is over, what we will do, we will do some few simple checks. Create a plot of the population, time series plot is more precisely, of the population over time. And we also save the result in Excel, for example. So the idea is what? So if you look at the pipeline here, we start from the API URL, we extract the JSON data, we send it to the R as an R data frame. So we will parse we will use JSON Lite to parse our data into an R data frame, and then we will do an analysis and visualization. Very basic things that we want to do today with the analysis and visualization. Without much further ado, let's go into R, and I explain to you how you can connect to the World Bank API. So you have R open. Now, you need to understand that in this course, you are assumed to have at least some basic knowledge in R. Uh, for the groups of people who do not have this basic knowledge in R, I've already given you materials on Google Classroom that you can go through to be able to learn R uh, independently, where you will know how to load the data and so on and so on and so on. Okay, so you will understand about data types, vector, and all these different things you will get in these documents that I sent you on that I posted online. So without much further ado, as I said, let's get into how to connect to an API. So we'll create a new script in R. I will do tile horizontally so that I can see partly my codes that I'm writing and partly my results in the console down there. To start with, we will need two packages. As I mentioned to you earlier, it is the HTTR package that will enable me, as I mentioned here, to send the request and check that the response is valid. That's one of the things that I will need. That is the HTTR library. I will also need the JSON Lite library. These are the two packages that I will need. Now, to be able to get these two packages, we'll need to install dot packages for the first time you are using that. This is done only once. You don't need to do that again and again. So you will basically here install these two packages. You can write it down like that, and you can write down JSON Lite here, and then you run it. For me, it doesn't matter much because I already have these two, but I'm still showing it to you. You will normally have to do this only once. As soon as you have done that, it's over. Whenever you are going to open R again and use R again and again, and if you need these two packages, you won't have to do what I'm showing you right now. You won't need to do that again. You'll click on OK and then you let it download. As I said to you, for me, it doesn't matter much because I've already downloaded this file, but I will still go through the process with you just to indicate what's going on. We need to be patient here. So it says it has downloaded HTTL successfully unpacked. We are not yet over. We have JSON Lite successfully unpacked. So we have these different packages have been successfully unpacked. But as I said to you, this you don't need to do again and again. So what I will do is I will put it as a comment, because if next time I'm coming and running this script, I don't need to run that code. So I just put it as a comment. A comment means that it is not executable. It is not a command that you want to execute. Just putting a comment means, for example, I'm explaining to you today something like that: World Bank WDI JSON. Let's suppose I'm explaining that to you. And if I want to write a comment, I need to always use this hashtag in R. So this is not a code. It's just a statement that you are making to explain your codes. So this is why when you put a hashtag, when you have to do Control A with all your codes later, you will see that it won't execute that. It will be basically just considered as a comment. Okay, so it will not be considered as a code or whatever. So by the way, let me put this down. You remember the parser? As I mentioned to you, this is what the JSON Lite is about. It's a parser, and we are going to use that today. Now, you have when you have installed these packages, the next step would be to load the different libraries. Load these packages. What are the packages that you want to load? You want to load JSON Lite, and you want to load HTTR. Okay, so you want to load JSON Lite and you want to load HTTR. This is something that you will need to use again and to do again and again. Each time you want to use a package in R, you have to load it. Obviously, when you have downloaded the package, it's only once, but using the package, you will need to do this use this library function again and again each time you want to use a package. That's very important to note. So we can execute that in the meantime and see if everything is okay. So you don't need to worry about these warning messages when you get them. Maybe I will increase my font size a little bit again. Let me put it as 24 so that you can better see it. So what's the next step now? The next step is that we need to build the URL. Already explained to you how to build the URL. All right, I've already explained to you how to build the URL, and I explained to you how you can go on Google and document yourself and so on. So first of all, I will give a name to my URL, and my URL will be within a code. Now, when we talk about the URL between a code, what do I mean? I need the HTTP path and so on. How do I get that? I explained to you there are different steps involved. There is, as I mentioned here, there is the base, the path, and the query. So what do we want here? We want to use Mauritius data. We want to look at the total population for Mauritius, and we want to start from 2010 to 2024. That is, we get the yearly data from 2010 to 24. And this is the URL that is built. And as I said to you, normally this interactive display is just for your information, play around and to get acquainted with this URL that is generated. But normally, if you don't have this interactive display, you will need to build it by yourself, as I've been explaining earlier. So we will just, for the sake of simplicity, I will just copy that link because this is the link that I want to use and this is the data that I want to plot. I'm not going to do for the NASA, but you will do it yourself for the NASA. You will see that there are other information that are available here. But me, I will focus only on this example. And by the way, for the NASA, you will know that this is part of your coursework that you will need to go through. So let me just paste that URL that I've just mentioned, just copied. You will see that I've pasted it in between quote, and this is my URL. Now, why did I give it a name? I'm giving it a name so that it doesn't become messy when I will write down my different functions later. What function? Let me just start by talking about that. For example, I can run that. You will see that it doesn't make any mistake because I put them in the code. It's just like a text that it is reading right now. Now I'm going to use the HTTL package to be able to get to query the API from the World Bank, and this is where I use respond, and I use this function get, which is available under HTTL, and get what? Get the URL. So get the URL. Just remember something. As I mentioned to you, we are using this function get from HTTL to send our request and check that the response is valid. That's the reason why we are sending this request. So to be able to send the request, it's always good for any API that you use to when you are using this function get, whether you are using it for our URL from World Bank or you are using it from for the power the power how do we say NASA API or whatever API you want to use, it's always good to identify yourself. For example, you will need to use another argument that we call user agent, and that user agent you will put down your identify yourself as a name. Now you have to be careful when you are setting out name. um, Basically when you are doing that you are just identifying the client to the server, okay? Sorry, you are just it just identifies you um, the to the server of the World Bank. That's basically what it is doing. uh, it's good practice normally to put a proper name. It's a good practice to put a proper name. That's very important because you will see that sometimes many APIs they may block generic or empty names. If you don't put a user agent, leave it blank, some API may block you, may not give you access. All right. So by identifying yourself, you can put your name, for example, or anything that you would like to identify yourself as. Uh, that's something that is good practice to do. And then when you are done with that, the next step is to do a timeout. A timeout, and I will put here 20 seconds. What is this timeout? Now, when we say the timeout, it means that if the server doesn't respond within that window of 20 seconds, the request, uh, how do we say, the request normally will yield an error normally. All right, that's what is going to happen. It will yield an error. That's normally what we expect from that timeout. Now, this is okay. So we can run this, and you can just check the response if you want to see if everything works. It seems like everything is working perfectly well. It tells you the date that you have sent this request for the API, and the status 200 means everything is correct normally. If the status was not 200, by the way, then it would mean that data could not be fetched information. That is, it could not connect to the API. All right. So if the status is 200, this is a code that indicates that everything is okay normally. All right. And then, of course, you're connecting to the API, which includes a JSON file. The next step um, is to extract the content of that URL. All right. The next step is to extract the content of that URL. How do I do that? Let me just type content, and the content that I obtained from the response. And as I told you, remember that the status of 200 is very important. If it is 200, everything is fine. But if you got another message rather than status 200, then you have to be careful, because you will have an error, or you might get some bad result later. So ensure that the status is 200 when you are verifying the response that you got. Okay. Now the content, how do I do that? I'm just going to extract the content as a text file. All right. When I talk about the content, what am I referring to? Let me go back to this. You see, this is what I'm referring to as a content. I need to extract the content from a JSON file. Now, of course, this is just for the country example. It's not relevant to what I'm doing right now, but I'm talking about the JSON file from that link. Okay, let me just open it just in case if I need it later. In the meantime, I go back to, here we go. It's quick. So I need to extract these data, and I'm going to take it as a text, and then I will tell you what I will do with that in a moment. So I will extract the content of this URL. I mentioned that the content should be considered as a text, and the encoding is equal to you will see here UTF-8. You can just type that down here. UTF-8. What is this UTF-8? Normally, first of all, let me talk about text. What text tells you, text basically, it tells the package HTTR, all right, that we have been doing here, use we have been loading rather. It tells the package to give you a character string. It tells the response to give you a character string. That's what it does, as I mentioned. And then the encoding of UTF-8, what it is a character encoding that is normally widely used on the internet, and What is it about? Basically, it's meant it is used in on the internet and computer system just to represent text. That's what it is. It's a it's an encoding that is used to represent text. That's what it is. If you don't have this UTF-8, you may get confusing messages. All right, in your content, you may get confusing messages. So what do we want to do here? We want to give it a name, obviously. Let's call it text, obviously, because it is a text that I'm extracting. Let's run this thing here. And then if you want, you can just have a look at the um, result. You will see that here we start getting the data of a JSON file. Now you will see that there are backslashes each and every time, backslashes each and every time. Now this backslashes is what we call an escape character that is used by R normally when it is when it is printing double quote. When it is dealing with double quote means this. If you have single quote like that, you have double quote, which is like that. So when it is dealing with double quotes, generally, what happens is that it will use a an escape character. Of course, this is internal to R. We'll not get into these details why it is like that. But R add these escape characters. Obviously, this is not something uh, very nice to look at when you look at this result. I would prefer to have it in a form where the data is not on only one row. So what do I do then? I can use this function cat of text, and then I say slash n. This this function cat, uh, what I've just written here, is also what we call the concatenate and print function. It has some advantages compared to a simple print function in R, where there are certain formats internal to R that when you use print, it will give you. For example, if I type print text, you will see that it gives you this one here, and it also includes this escape character, as I mentioned, which is internal to R, given that will include this escape character each time it is dealing with a double quote. All right. But we don't want all these. This is why we can use the function cat, which is a function that write the raw string to the console exactly as they are supposed to be. All right, that is, it doesn't bring in any additional formatting that try to bring in. By the way, when you see slash n, not to confuse with this slash here, slash n means a new line. So let me just give you the example between these two. So for example, when I run this cat with slash n, the slash n represent what we call a new line. Okay, that's what it represents. It represents a new line. So you will see that when you run this cat text new line, that's what you get. And then when I say new line, it means that after having reached that, let me just run that again. You will see that when it has finished at the end of the script here, at the end of the script, you will see here, it moved to a new line. That's what it means. But if I don't put that, let me just show you what it looks like. If I don't put that, you will see that the arrow that is the next command is not uh, placed after the result here, but it is placed just next to the result. This is not very good because it means that you need to type your command here. That's why it is essential to bring this new line each time you write this cat, just to start a new line basically. Now the cat, as you will observe here, a The CAT basically has removed all these escape characters, which are formats that are included. There is something else. If I want to see, for example, a nicely formatted JSON file, rather than seeing it like this in only one row, but if I want to see it in the same way like this, something like that, then let me show you what we can do. Again, I will use this function cat prettify and then text, sorry, text prettify will make the JSON file look far better. All right. So this is available from the JSON Lite package, just for information. It's available from the JSON Lite package, not from the HTTL package. The prettify function is from the JSON Lite package. And don't forget our new line that we need to include. Our new line. This is important. Otherwise, as I just explained to you, your command will be on the same line. So then we are going to execute this, and you will see that we have again right now in front of us our JSON file, as you are seeing here, and you will have all the details. We have a metadata, as you see here. You have an indicator, you have for year 2024, and then you have for year 2023, the next one. Next object is 2022, and so on and so on and so on. So here it's nicely formatted. This one is the raw line as it is. What's the next step now? Our next step is to, as I said to you, this JSON Lite package is a parser in the sense that it takes the information from the JSON file and make it an R object, object. Right now, this is just a JSON file. That's what it is. There is not much we can do with that file as it is right now, unless we convert it into a form that is appropriate for us to analyze in R. So basically, we will need to take that JSON file from where it is, bring it into R as an object, for example. And when you bring it into R as an object, then you can start manipulating it. That's why I mentioned to you this term of parsing that I mentioned earlier. All right. Now, what we want to do is we want to say from JSON. That's how we write it. It's a function from JSON. We are going to use our text and we're going to give it a name. Let's call it WP. From JSON text, I will add another argument. I'll explain to you what this means in a moment. True. The first thing I want to talk about is this flatten is equal to true. Now, by the way, WB is referring to World Bank. You could use whatever name you want. Now, when I talk about flatten it equal to true, what is the purpose of that normally? When you are mentioning flatten is equal to true, you are basically asking JSON Lite to flatten what we call nested list into columns when it is possible, obviously. You need to understand that here in our object that we have here, let's have a look at the data for 2010. You will see that there is an object here, and then you will see that Uh, there is also another object, but let me go up there. Just a second review. Yes, you will see here that to start with, uh, this information that we have here, there is a list, and in that list, which contains the metadata and also which contains our different objects, as you are seeing, that list, there is another list. So there are two things here. The number one in the list, in the first list, you have the metadata, but you have a second list here, which is a nested list, which is found inside of that bigger list, if we can call it. So the fact that there is a nested list here, there are certain things that when you will get the output from WB, if you did not put the true, will not be very convenient for analysis later. Let me just explain to you quickly. Let me just first of all run that, and then I will show you the difference, what I mean by flatten is equal to true, for example. Let me run that. Now, when you look at WB, bon, you will get your table as you are seeing here. You will get your data, which contains the first list, which contains the metadata, as you are seeing, uh, that was given earlier. And then you have a second list, which is a nested list, which contains all the other informations that exist in the JSON file, as you are seeing here. You have a country value, you have a value itself, you have all these different information. What is the difference between these two? Maybe to better understand that, let me just run another one. So you understand that WB is for flatten is equal to true and flatten is equal to false. The whole thing about that is just to the whole thing about the true and the false is basically for the purpose of analysis, the way that the data will be presented. Okay, let me just give it a WB1. I call it a different name and I run it as well. I've run already this one first, and then let me just check the structure of the data. I'll show you the difference. We do str of WB and we do str of WB1. Remember that WB1 is for false and WB is for true. We are going to run these two and then I will show you what's going on here. Let me just maybe tile vertically, it will be easier for us to follow. So here we go. You see, if we consider, for example, this one WB1, which was when I said flatten is equal to false, we can just briefly have a look at here. There are two lists, one which contains metadata as you are seeing, and then the other list which contains the data frame, which involves different objects. Obviously the data frame, we refer to that in the jargon of R as data frame, and that data frame contains 15 observations of 8 variables. All right, 15 observations of 8 variables. Now if we flatten is equal to true, look at the difference. You will see that now it is not 15 observations of 8 variables, but of 10 variables. What's happening here? What is going on in there? To better understand what's going on in there, you will see that in that particular list, for example, in that particular list, let's suppose I'm interested in the indicator ID. In the indicator ID there, I want to extract that indicator ID information. Only that is indicator ID. information. What I will normally have to do is to call WB1, and then I will say dollar, but dollar each means calling. You will call the second list, all right? But now listen to me. Not second list, you will call the indicator from the second list. Now, given that WB1 contains two lists, there is a first list and a second list. Normally, I can't, if I want to extract information from the second list, which is a data frame and not the um, metadata here, what do I want to do is normally I will write down this in this form. WB1, um, you will say WB1, you will use this square bracket of 2 to refer to the second list in that object that I've got here. You will refer to it as the second list. If you want to obtain the first list only, you will need to use WB11. Let me just show you this, for example. Excuse me. Let me just show you that B11, it will return only the first list. If you want WB2, it will return the second list, and you need to write it down in that format here. I'm not going to get into the details of what these squares mean. Of course, there is a concept of array and everything in all that I'm avoiding to escape. I'm avoiding to explain here. But just for information, if you want the second list, you will need to use uh, this form here. Now, in that second list that we are using here, what happened is that I want to get, for example, in WB1, 2, that is in this data frame, I'm interested, let's suppose, to extract the indicator ID. So if I want the indicator ID, it means from the second list, I need to find indicator, and from indicator find ID. So if I want to extract that, I will need to write there be one, and then I will put dollar, which calls from the WB11. You from WB1, you are going to call from the second list of WB1, you are going to call this indicator as you see here. And from that indicator, you are going to call the, remember that R is case sensitive. It is important that when you are writing things down, you write it as it is. Don't write it in whatever way you want. You will need to call that to be able to extract this information. Let me just check what I got wrong here. Sorry, I'm looking for WB1 too. Here we go. This is what you get. You get to extract the indicator ID from for each year. All right, that's what you have. Now, this is a little bit not convenient, especially when you're dealing, when you want to analyze your data. When you want to analyze your data, you don't want to get things to get into such levels of details where you are going to have to use all these callings. But to make things a little bit easier, what happens is that when you're using flatten is equal to true, that makes things a little bit easier because it converts this these nested information here, that is the these information, it converts them into a single column. Like for example, instead of having a indicator and then under indicator you have ID and then under indicator you have value, it just basically makes um, it simpler. How? This is how it does it. You will see that in your data frame you have simple columns without any issues, where now indicator is where now ID is not referred to as ID but becomes indicator.id, and value becomes value.indicator.value. So what is the advantage with that? The advantage with that is that from WB, from WB, again from WB2, the array, we just need to call dollar and then we call indicator.id. That's how we get it easily. So it has created the flatten is equal to true, as I have mentioned to you. It flattened that nested list into columns when making things much easier for you to analyze compared to the other one, which is not very straightforward, especially if I had to get into this indicator $ID. I might not know that I have to go two steps further to get this ID. All right. So to make things far easier and neat, this is why we do flatten is equal to false. It makes the structure of your data frame more easy to manipulate. That's basically the end of it, what I wanted to say. It makes it far easier to manipulate. For example, here you will see that it's just a matter of .id and it's over. Instead of writing call each time, you just need to WB2 and then you put the name of uh, um, the variable that you want to plot or the variable that you want to analyze or whatever easily rather than doing a second calling. You see, here you do already one call for indicator, then you do a second calling for ID. Here you do only one call, and the one call is the column indicator ID, which when you do flatten is equal to true, it automatically creates it for you. So what is the purpose of that? As I said to you, is just for data manipulation and data uh, for working with your data in an easier way. You may not see the use of it right now. You may not see the importance of it right now, but when it comes to analyzing your data later, you will see that such types of small things makes life far easier for us to do some basic manipulation in R. The next step is that you can, for example, extract that WB2 as I've just mentioned. WB2, let me just show you. You have WB, yes. So if you want, you can extract WB2 now because we are interested in the one that has been flattened. So if you are interested in WB2 completely, you just need to type WB2. This is the data that I want to work with, by the way. This is the data that I want to work with. But you will see in that data that I want to work with, there is unit here, which is blank. There is observation status, which is blank, decimal, which is zero. All these are things that I may not be interested in keeping in my data to work with because these are blank missing values and so on. So first of all, let me just give it a name because it is my final data that I want to, not final, but it is my data that I want to work with. So I'm just going to call it data, and then I can view data if I want in the form of a spreadsheet by typing capital V IU. I get this in the form of a spreadsheet. Now, again, unit and observation status and decimal are useless. We don't need these information there. I will explain to you how we can get rid of that. But quickly, you can check the structure of your data again, and you will see that now the structure of your data is a data frame of 10 variables, and it tells you what are the different data types that you have. You have character, you have integer, you have character, and so on and so on. So it's always good to have an idea about the structure of your data, especially that sometimes you might want to convert character into categorical. Sometimes you might want to convert integer to, uh, for example, numeric, and so on and so on. All right. So what do we want to do now? I want to build my data again. I want to get my final data without this these, for example. I would like to keep maybe this also. I don't need it. I don't need that MUS. I probably need the date, the value. I will probably need the indicator ID and the indicator value and the country ID and the country value. If country ID and country name, which is a country value here. To do that, I override my current data by replacing it with a new one. And to replace it with a new one, it means that I'm going to retain certain columns. I don't need this country ISO code, but I will retain certain information like I told you: country ID, country value, indicator ID, indicator value. I will retain the obviously date that I want to retain. I will keep that, and I will keep the value. Obviously, this is very important, and that's basically what I want to do. How can I do that? By disregarding all the other information, I create a new data frame. A data frame in R, by the way, for those who are not used to that, when we refer to a data frame in R, we are referring to data where you can have different data types. All right, the data frame is gives you the possibility rather of having several data types. Like here you have character, you have integer, you have two different data types in only one data frame. uh, and it gives you your data in the form of a table, like you can see here. For example, it's a table sort of look like, which gives you all your information uh, in the form of a neat table, and also where you have different data types that can be included in the data frame. In a vector, for example, in R, when you're using a vector, like what is a vector? Let me just show you. I think I've wrote that here. This is a vector in R. And when you are writing a vector in R, this should be the same data type. For example, you saw that I wrote a vector of two different information which are of the same type, which are text here, which are character. But in the data frame, you might have different data types. Just for information, I wanted to say. So what I want to do is I want to extract, let's suppose, country ID. That's one of the information that I want to extract. I put it there, and then we'll come back to that afterward. Let me just put a comma here. I'm not done yet. I want to extract the country value, comma. I want to extract the indicator ID. It depends on the order I want to extract this information. I'm extracting it like that. Indicator value. I want to extract date for sure. I want also to extract the value, which is very important. This is what we are working with, by the way. Now, with all these, there is something else that I'm going to add to it. Let me just write it down and then I explain to you. Strings as factors. Note something. Remember that in R, it is very important that you write down things as they are meant to be written. That is, if there is capital letter, you need to write capital letter. If you have a small letter, you need to write small letter. That's very important, you know. So my data frame consists of all this information, and I will explain to you what this is about. String as factors equal to false uh, in the end. I just wrote it so that I don't forget that I need to mention it here. But let me just mention quickly what it is. String as factors means do not convert all character variables into categorical variables. That's what it means. If it sees something that is meant to look like a categorical variable, don't convert it and keep it as character. That's what I mean by string as factors. By the way, the word string means strings means text in R. Factors in R means categorical data. So when I say string as factor is equal to false, it means that do not convert my text data into categorical data. For example, date, do not convert into categorical data. It is not a category of date, another category. That's what I mean by that. So having said so, let me go to the country ID. The other thing I want to tell you now is that in R, if you want to call country ID, it will not work if I do that. Let me just show you. If I do that, create a data frame, a it will say error. It doesn't recognize all these unexpected symbol. I will not be able to do to I'm not able to show you clearly what it is here. But the idea of the data frame, including all these different information, uh, is not working, not because of the reason why it's not working here is not because of what I'm going to explain here. But normally, when you have country ID, if I just run the country ID, you will see that it does not recognize this. It says error object country ID is not found. Why? Because if I want country ID, I need to say where I get this country ID. I get this country ID not from WB11, but I get the country ID from WB2. Not from WB12, but from WB2. So, and DWB2 has been called data. So I need to say from data fetch country ID. And this repeats from data fetch my country value. That's basically what we have to do. From each of these, fetch the different information. There is only one thing, though, that you will see I would like to do is that from the data date, you will see that data date is character. But normally, I don't want this to be treated as character. I want it to be treated as integer so that I can use it later. So if I want to treat as an integer, I need to say as dot integer. This is a function that will convert the character into an integer. That's what it does. It converts the data from character to an integer. So that's what I do. And the other thing now, having said so, I will probably want to give a name to all these data frame, to this data frame. I would like to give it a name. All right, I would like to give these different information a name. So what name I want to give them? For example, I will say country ID is equal to. That is my data now. You remember data, how it look like. Data contain, I think I forgot to run that. Let me just run that first. So you will remember that data contain country ISO free code, date, value, and so on, observation status, and indicator ID, and so on. So, for example, the date is basically year. So I can change that as I want. By the way, if I just remove that, let me just run something now. Okay, it doesn't matter. Yeah, we can give it a name, country ID equal to, we can call it country name equal to. The other thing that I want to mention in R, when you are giving a name to a file, it's okay. It's always good that in this particular context, when you're giving the name, you don't put a space. All right, just put it underscore if you want. All right, if you want to deal with the space, that's a different story, but put it as underscore right now. Indicator ID is equal to data indicator ID, and then you have the indicator value, which is basically the indicator itself, and the as integer date is normally the year. I will call it year, and the value is a data value. Now just remember, I just showed you data. You remember the codes were date, value, unit, observation. Just remember that, okay? The name here is date, value, and so on and so on. But you will see when I put these different name, obviously, when I'm going to read my data frame again, my data frame, first of all, will not contain this information. And in addition to that, their names will not be the same as it was before. Maybe value will stay the same, but date will change to year and so on. That's what I want to do when I'm doing this. And string as factors, I already explained to you anyway what it means. So what I will do is that I will run this now. For certain reason, I don't understand why this is not working properly, but it's okay. Let me run this from time to time, and then let me run this data frame again. So let me just check what the issue is. Hold on a minute. We got it. We need to remove this. The fact that I put it as this way, normally data is being treated as a data frame. So basically it is thinking that data frame is being given a name called data, and it doesn't work, obviously. All right, so data frame is a function here which contains all these information. So normally you need to put the rounded bracket just next to data frame rather than on the new line as I've done earlier. So it should work normally now. Let me just try this out. First of all, let me run this again just to ensure that uh, data is not about the data frame. Let me just run this again. As you will see here, now it works perfectly well. All right. We can check. We can check the data in the form of a spreadsheet again, just to see how it looks like. Here we go. We got a neat data table. We got a neat data table with country ID, country name, indicator, year, value, and so on. So this is the end result of what we got. We've made our JSON file, which was semi-structured, become in a form that is structured for analysis. Remember where this came from. Remember, this was our data. Now, from that, we've been able to, using the JSON Lite parser, we made this file become in an R object that we can now analyze without any problem, and we can work on that structured data now. Remember, I repeat, we came from that to that. We came from that to that. So what's our next step now? Our next step is to do some basic. We've been able to do to get this nice data frame, as you see. I will show you in a moment how we can bring, how we can write down that data file in save it somewhere. I will explain it to you later because I will want to add some additional information in this data frame. For example, I would like to include the percentage increase or percentage decrease in the population year over year. So this is why I'm going to wait a little bit before I save the file. All right. But let me just do some basic data manipulation now. Um, First step, I want to do some basic checks. We can see if you want. Okay, there's no need to do that. You already know what it is, but still, I'm just mentioning it here. A few things just to get you used to R. If in case you want to do something like that, you can calculate. You can get the year range, and then I put a space here, and then I put comma, And then I say, what are the year range? The year range start from minimum. Remember that this CAT function allows you to concatenate different information, including text, which is between inverted comma each time, and any value or anything that you want to write. So I want to get the minimum of data dollar here. Remember that this data dollar is essential if you want to call year. Year does not exist elsewhere. It exists only under your data frame that is named data. So each time, whenever you are calling a variable, whether indicator ID, whether country name or whatever, you have to call it from data. And this is why I need to put this operator here. This is the dollar sign, which used to show what is a search path. So you are saying the year range is, for example, 2010, and then you put 2 comma, and then you put the maximum of data dollar year. And again, as usual, when you're working with CAT, it's always good to put this new line at the end. So we can control here, and then you will see that a result appear, which is year 2010 to 2024, which is a very simple thing, nothing complicated about that. Then the next step I want to do is to do some year over year matrix. What are the year over year matrix? First of all, I will sort um, all this data to newest first. Why? Because you would recall, if I do view data, you will see that the newest appears first in the first row, and then the oldest comes in the low in the 15th row, for example. So what I want to do here is to change that. I want to sort the data by obviously year. Remember that year has already been converted into integer. By the way, if you want, you can just quickly check your structure of data, and you will see that year is integer in a perfectly well converted. So the year on year matrix, to be able to compute the year on year matrix, first of all, let me order the data. So how do I order the data? It's again, I'm overriding the same data. I'm not giving it a different name, the ordered data. I'm overriding the current data by changing it from uh, newest to oldest, by changing it from what it is right now, that is newest to oldest, to oldest to newest. Okay, that's what I want. So how do I do that? I will say data, and then the square bracket represent an array in um, R. You may wish to investigate what an array means in R by searching array in R. Okay, you have one dimensional array, you have two-dimensional array, and more than one two-dimensional array. A one-dimensional array is basically a vector. A two-dimensional array is like a matrix. Okay, like here, if you look at the data frame, you have a set of rows and a set of columns. So if you are talking about data square bracket, um, you're talking about data square bracket, it means that you will have to deal with number one, rows, and then number two, columns. So what I'm doing here is that I want to order all my rows in my data. This is why I'm writing it on this side of a comma. And on the right side of a comma represent the column. What do I want to order? I want to order, let's suppose, only year. I want to sorry I want to order, for example, indicator. All right. I want to order only indicator, or I want to order only indicator by year, or I want to order only value. Let's make it more sensible. I want to order value by year, only value. Then I will have to put value here. But the fact that I want everything to be ordered, in any case, the others won't have any impact in any case, because everything is repeated here. So, but still, if I want to keep it blank, it means that it will order all variables. That's what it means. When you keep it blank on the right, all the columns of a data will be ordered. When I say columns of a data, I repeat, when I say columns of a data, if you look at the view, you See, these are the columns that I'm referring to as they are seen here. Now, order what? You want to order data by year. You want to order the data by year, and that's what it is. You order the data by year. By default, it is going to be in ascending order. So we don't need to worry. We just run that, and then you can view data again if you want. You can copy paste that down there, or you can just run it from here. It doesn't matter. You will see that now the data is in terms of 2010 to 2011 and so on and so on and so on. Okay, so the data has been sorted correctly. You will see the values are here. That makes sense, and we can move on to compute our year on over year change. So let's start by doing a data dollar year over year change. Now, to compute the data year over year change, what I need to do uh, when I'm talking about a change, just run that quickly. What I mean by that, I want to compute the change in the value. So it means that I'm going to compute 1,252,404 minus 1,250,400. All right, 250,400. So it means that you will have 2,400 as a difference. Now, but the difference will be placed in the year 2011. That is in the second row. The first row will be normally a blank because you don't have anything before the first row, so it will be considered a blank. So what do I need to do when I'm computing this um, year on year difference? I need to include a missing information. In R, an A is used to represent a missing information. In R, I repeat, an A is used to represent a missing information. Maybe I will tile or vertically again, horizontally rather. This is my data. Let me just close that. So here we go. You've got the NA, and then I will do the difference. To do the difference, there is a function in R that we call diff. Diff enables you to do the difference between whatever data values that you have. So whatever data that you have. So here we want to do a difference of data value, as I mentioned to you. This value subtract this value, and so on and so on and so on. Okay, but um, it's not necessarily this one because this one was on the former data. So we are talking about here, we're talking about the new data that has been plotted, that has been written 2010, which is this value subtract this value and so on. The first will be a blank. So this is why I added it in my vector down there, a blank, which is going to be included. Then I close this bracket and I'm going to run that, and I can just run this data year on year change to see what happened. And as you see, 2004 to 3000, 2004, which is a difference between, just give me a second review. I'm going to run that again so that we can see it better. So this is the difference between this year 2010 2011 and 2010. So 2000 1,252,404 minus 1,250,400. The difference is 2004. I think I'd said something wrong earlier, if I'm not mistaken. So the answer is 2004. And then the difference between these two values that I'm highlighting right now is going to be 3,473. So we can already see the year on year change. If you want, you can view the data because you have already created it. You see, you have already annexed the year on year change to data. So if you have appended it there, you can already view on the right completely that year on year change has been included, and you will see the negative value as well, indicating that the population size is decreasing since around 2022. All right, there is a decrease in the population size. So let's move on. The other thing that I might be interested in doing is to compute the year on year percentage. All right, the year on year percentage. Let's give it a name. See, by the way, everything that you see on the left of the arrow is going to be a name that you give to whatever you have on the right. And that name that you get on the left is going to be what we call an object in R. It's an object that we call it in R. So this depends on your name that you want to give it. Anything that you want to call on the left, it's up to you. You decide what you want to call. I put data here. I put data here. On the left, I put, for example, WB. On the left, it is all up to you as long as this name is easy for somebody who's reading your code to understand. That's very important. So we need to compute the year-on-year percentage now. we Again, when we are going to compute this year on year percentage, we indeed again need to include, because we just like the same thing like the change. If you want to compute the year on year percentage, you need to include the NA, the missing, because you will miss one, which is going to be the first observation, obviously. Maybe I will, before rounding off, let me just explain to you how I'm going to do that. I will find the difference between of data value, just like I did earlier. I'll find the difference of a data value. But the difference of a data value, I will need to divide by a certain value. What certain value? I will need to divide, for example, in my particular case here, I will need to take the difference like the 2004, but divide by the old value, which is 1,250,400. I need to take 2004. So it's new minus old divided by old if you want to compute the percentage. The new value minus old value, which is a difference, divide by the old value. So I repeat, diff of data value means the new value minus the old value, all right, divided by the old value. In the new value minus the old value, which is 2400, 2004, new minus old, divide by old. Old is 1200. How do I get to write this down? Remembering that we need to understand that the last observation of value will not be taken into account when we are computing. And this is essential because we need to ensure that both arrays are the same size. When I say both arrays are the same size, I mean when we are dividing by a value here, the number of observations that you have in what you are dividing should be the same number of observations that you have up here. So if you have 14 observations for this one, you expect to have 14. You cannot have 15. So this is why we need to find a way of removing the last value from the computation when we are dividing. So the removing the last value, this is why I'm going to write a function called head. I'm going to explain to you what this function is in a moment. So function data value, and then I put comma, I put last value is -1, and then this is, I need to close the bracket for this all C. And the other thing I also want to do is to multiply this difference that I'm going to get in terms of percentage. In addition to that, I also want to round off these figures. I want to round off these figures. You see, just don't forget what the brackets are for. So you have this bracket, which is for this head function. You have this bracket, which is for the round function, and the last bracket is for the C function. So what I want to do here with this round function, I want to add another information, which is to round it off to the nearest three decimal places. All right, that's what I'm doing. I want to round it off to the three decimal places. So that's basically what it is. Now let me get back to this concept of head. head data value. Normally, this function head in R, if you say xn, head of xn, what does it do? It returns the first n elements. It returns the first n elements of x. All right. So if you say x data value and free, it will return. If you say x data value, if you say head of data value comma free, you can try it afterward. You will see that it will return normally these three first values. But me, what I want to do is that I want to ensure that the last value is not included. The last value is not included. When I mean the last value, let me come back to that. I mean this value is not included in the computation, the 125,000. So I don't want to include that in the computation. How do I do that? Normally, in the head function, if you say, for example, negative 1, let's suppose, if you negative 1, if you say head x negative 1, negative 1, what we will do, it will remove it will return one value less, all right, which is it will return all of the data but without the last element. That's what it is. If you say -2, it is supposed to return it will return everything except the last two elements, and so on and so on. So this is important so that you don't introduce the n so that you don't not introduce but you don't get a problem when you are dividing by um, you are dividing 14 values by 15 values. You see, this is why I need to put this negative 1. You can just have a look at it quickly. You will see if I run that part here, you will see the last value has been excluded from this code here. We can just view data again. You will remember, if you forgot, the last value was this 125,000. So the last value has been removed. Now, having obtained my different, how do we say, year over year percentage, I can compute it and just have a look at what it gives me. As long as there is no error, it's fine. If there is an error, then it's a problem. So you will see the first value is not applicable because I've introduced it myself. And you have the rounding off that is going on. How do we know if the rounding off has been done well or wrong, as is right or wrong? It's very simple. We just need to use the year over year percent change rather that we got, the 2004 that we computed, which is a new minus old, and then we just need to divide by this. Let's just confirm if what we are doing is correct. We need to divide by old, and you will see that you got 0.00160, which is the same, but of course converted to percentage because we have multiplied by 100. You will see that it is the same. So that's working perfectly well. Our year-on-year percentage. Why am I doing that? I'm saying again, is just to get meaningful information from that data set that we have obtained. We want to know what is the percentage change in the population and so on. So you can just stop, run data now, or view data again, and you will see what happens. You'll see here that there has been an increase from 2010 to 2011 of 0.16% in the population size. However, since 2022 to 2023, sorry, since 2021 to 2022, there has been a decrease of 0.3%, which is relatively big, 0.3%. So we observe a decline in the population of Mauritius size, in the population size of Mauritius, as you are seeing since 2022. Okay, so that's okay. What are the other things that I want to do with you? Maybe I will now do something like, let me just plot these different values. Now that we are not going to add or remove anything from the data or do any manipulation on the data as such, except drawing plots, what I might want to do is to apply the attach data attach is to apply the attach function. The attach function normally will bring data into the search path of R. What does it mean by into the search path of R? It means that now that I don't, it means that when I say attach data, it means that I don't need to write this each time what I'm highlighting here. You will have observed that each time you are calling for a variable, as I explained to you earlier, you need to use this dollar operator from the data. Okay, if you were using WB, it would have been WB dollar, but if you are using data, it's using data dollar. Now, the thing is, if I don't want to call this data dollar each time, I can just use attach data, and that would help me a lot. For example, I can plot the year and the value. What does it mean by plot year value? It means that on the x-axis I will have year, on the vertical axis I will have value. So plot is a generic function in R that is going to be applied based on the structure of your data. If year is integer and value is integer, logically the plot is going to be a scatter plot. But if I don't want, if I just run that like it is, you will see that I will get a scatter plot, which is not good, right? I forgot to attach. Just give me a second. Yes. So you will see that if I did not attach, if I call here, it doesn't work. But when I attach, it works. So you will see that I get a scatter plot. Obviously, this scatter plot is not something that you would want, obviously. You don't want that scatter plot. It's not good. You want these points to be connected by lines because you are drawing a time series graph. A time series graph means you're drawing a line graph normally that connects these different points over time. And how do you do that? You just add another argument to that function plot, which is type is equal to, either you can put L or you can put B. It's up to you. All right. For example, if you type B, it means broken line, as you are seeing now. It is different from what you had earlier. So if you type L, you will see that now it becomes something like that. Okay, let me just try to put this, to divide the screen into three parts like that. So you will see now better. But I prefer the B, so I keep it the B here. Now, the other thing that I want to do, I can do comma, and then I do enter. Now there is no need for me to worry. I can continue writing down there so that you can see what I'm writing. The other thing that I might want to do is you would have seen that the limit is from 1,000, 1,000,000 to 150,000. I can change that if I want, and you will see that the limit here is 1,265,000. But I can also increase that if I wish. If I want to change that, I can do xlim equal to c, and then I put the lower limit of the x-axis and I put the upper limit of the y-axis. But sorry, the lower limit of the x-axis doesn't apply here because we are talking about the year, which is the lower limit, which is 2010 and 2024. This I want to keep it as it is, but rather the y limit, excuse me. For the y limit, I will start, let's suppose I decide to start from 1,245,000 up to, instead of 1,265,000, I say 1,270,000 rupees. All right. So if I run that, you will see that the let me just run that quickly. So unexpected symbol, just a minute with you. I think I missed something. No, no. Just hold on a second. Let me just put that on the single line so that I see what's going on. See, it's okay. I think I should write it on the same line then. Normally it should have worked, but it's okay. Here we go. I don't know what happened earlier. Maybe I put a space or something like that. So you can put the while here. Mm, oh yes, sorry. I know what happened earlier. I just run this while which is not correct. I need to run the whole thing. So this is one thing that I can do is to improve this. You see that it becomes 1,245,000 to 1,270,000. Then I can even improve this a little bit further if I want. For example, I can change the character of these points. Instead of having it like that, I may wish to change the point character by saying PCH is equal to 18. PCH is equal to 18 means you will find the points change from a circle like that to a dark circle. Normally, sorry, I need to run that full here, to a dark circle or dark square like that. You can play with these point characters. How would you know what point character to use? Just Google and you will know what point character to use. I can increase the line width because I guess you might not be seeing it well right now on your screen. So I can change it, let's suppose to 3, for example, and then run it, and it may be you will see whether you are happy with that or not. Maybe this is better for you, so you can keep that. I can even improve it further and do color is equal to, not improve it, but I can add other information to it. Instead of having a black line, I can change it to blue line. um, for example, sorry, each time I'm running this last line. So here we go. It changes from black to blue. What else can I do? I can also put a title to this. I don't have a title for this graph, so I can say title is used by the function main, by the parameter main. The parameter main is going to bring in a title to this graph, so I can say evolution. You will see that each time in R, when you're typing a text, you need to always bring it in between inverted comma. Evolution of population size in Mauritius, of Mauritius rather. And then after that I put a comma again because I need to continue adding other information. Let me just run that quickly. You will see that a title has been added to your plot, as you are seeing here. You can keep on improving this. For example, the X lab, it is here a small letter Y, and the value is just value. It's not very nice. You can change that as well. So how can I change the X label? I can change the X label through the parameter xlab, and I give it a new name. Instead of here small letter y, I put it as capital letter Y. And then I change that Y lab into something else. Sorry, the Y lab into, instead of having value, I would prefer to have something like population count. So I say population count. Okay, I say population count, and then I control R. I run the whole thing, and you will see that now it is capital here, and then this has changed from what it was value as default based on the variable name that you add in your data, and has been changed to population count. And then the other thing that I might want to do is to remove that big box surrounding that graphic. For example, I can do that. For example, I can do frame.plot is equal to F, or false if you wish. You can write this down. You will see that it removes that big box. So what we have just done here is that we moved from a semi-structured data where you could not do much with it, brought it into R through an API where you've got the JSON Lite has been acting as your parser, and wrote the data from your API into an R object. And from the R object data that you obtain, we have improved it and cleaned it by removing missing columns, and so on. And we have even added some additional information to it. And in addition to that, we are now drawing some basic graphics, as you see here. This is the time series graphic. So that's how you move from a semi-structured data to something that makes sense in front of you. The other thing that you want to do, let me just show you. I created a blank folder here. I created a folder which is lecture 3 results, and I want to bring in, for example, that data that I've written. That is this data, the last one, that I've been working and amended. Of course, I don't want the row names there. I want to have all the country ID, the country name, the indicator, and everything that has been cleaned, and including, of course, the year-on-year change and also the year-on-year percentage. So what do I want to, how do I do that? If I want to do that in R, I need to use a function called write.csv. By the way, it's the same function, not the same, but there is another function that we call read.csv that you can use. Look at the way I'm going to explain it to you for write.csv. You will normally do something similar in read.csv, except maybe one thing there. Right. So when you're talking about write.csv, you need to say what data you want to export as CSV. Of course, the data that I want to export as CSV is our data itself that has been named data. And where do you want to export that? I will need to say where I want to export that. So I will come in my folder here, and then I will click on that taskbar here. Just note that on that small bar here, look at it well. I click on that. When I click on that, I get my selection. I just do a copy of that. I right click and copy, or do Control C, whatever you want. You copy that path. And then you are going to paste that path here. But be careful. What I want to do in R is that I will need always in R, when you are describing a path, you cannot use that backward slash. You need to convert that backward slash into forward slash. But you have to be careful, because if I'm converting this backward slash to forward slash, I can come and do it manually one by one, but that's going to take a huge time, obviously. All right. That's going to take quite a long time to do. All right. So what I can do, I can do a Control H and replace the backward by forward, and it does it automatically. But the only issue that I have here is that if I do that, you will probably get into trouble if I replace all, because there are different places that I have been using backward slash that meant something. So what do I need to do? Maybe it is better to create a new script, and from the new script your you paste your path, and you do a Control H and replace backward by forward in that new script, and then you ensure that there is no problem with that. By the way, when you reach the end of a path, as you are seeing on the right here, I need to also give a name to that file. Of course, it is the data of that is named data that I'm exporting here, but I need to give it a name. And what name do I want to give that data? I want maybe I can call it population, Mauritius population, Mauritius population. Let's suppose I call it Mauritius population, but I also need to ensure that it is contains its CSV, its extension. I mean, you need to put the .csv. So here you put the path before that, and you are now putting the name of that file. So I copy that whole thing here, and I'm going to paste that in between the inverted comma, as you are seeing here. I place that in between the inverted comma. It's a bit the same principle in reading a CSV file, by the way. But the only difference in the CSV file is that you won't have the data because you don't have the data yet. So this read.csv will just include the path basically and some additional information if you wish. The other thing that I told you earlier is that you would recall, let me just run that for you to understand what I mean. You would recall when I've said view data, there were row names that were here. I don't want these values 15, 14, and so on, which are the row names that are in R. I just want the data without the row names. So if I want the data without the row names, I come here at the end of that write.csv function and I say row.names is equal to false. By doing row.names is equal to false, I ensure that when I'm going to export that data in a CSV called Mauritius population.csv, I won't have an unnecessary additional column. Remember, when you're doing that, you need to always change your backward to forward slash. So let me write this down and I will show you what is going on here. You will see my screen here and I'm going to write this down and you will see that it will appear here. As you just saw, it just appeared here and you can now open your CSV file, which is a neat file, which is here, where you have been able to do some additional computations to your data. All right, maybe some of these you won't use, but I'm just keeping it here. So you've got the year, you got the value, you got the year on year change, you got the year on year over year percentage, year over year change that we have computed. If you want, you can just check and verify if this is working. You just do this here and subtract this value. You'll see the same thing. And if you want to confirm for the 0 0.6, I already confirmed it, but if you want, you do new minus old divide by old, as you see here, and you can just run that for the others. You will see that it is basically the same. If you want to multiply by 100, here we go, you will see that it is becoming, it's basically the same thing as we see here. It's basically the same thing. So you've been able to remember, move from what step to what step. Let's just do a quick um, recap here of what you have done. We have moved from that semi-structured file, as we refer to it, a JSON file, as you are seeing, that is obtained through an API, the World Bank API. We've moved from that file here, which is semi-structured, where you could not get much value out of it, to what you just saw here. To what you just saw here. Been able to move from here, there, to here. And all these by connecting to the World Bank API, we got all this data. Obviously, the same thing, you could have achieved it by going into the World Bank and downloading the data CSV directly. But here, the aim is to show you how to use an API, and this is why I chose the World Bank. So the API enables you to download data from its website without any issue. All right. Uh, that's a little bit all that you have. Now I will give you some exercises to do. Now, when I'm going to give you these exercises, you have to understand something. Is that these exercises, some of you will be relatively okay with these exercises, but some of you may not be okay with these exercises that I'm going to give you. All right, because you are not necessarily used to R. This is where you will need to do some independent learning, all right, and try to figure out how to do it, even if you don't know much about it. It's at the same time give you the opportunity of learning R and trying to apply it here. So what do we want to do? These exercises, let me just copy my questions that I want to give you. Number one, I want you to do that. I want you to compute the average. What you want to do in R, I want you to compute the average year over year percentage since 2010. Don't forget to ignore missing values. How would you do that? You need to go and do some independent learning. I did not teach you that. I want you to do that on your own. Doing a study on your own and try to figure out how to do it. In any case, I'm going to give you the code later on. It's just basically one line of code. It's not that complicated, but you need to understand what to do in that one line of code. Now, the second exercise I want to give you here is to find the year with the largest, let me just copy that. To find the year with the largest year over year percentage change and show just that year and its year over year value. Now, this is very simple. You just need to browse through it with your eyes, but you need to do it in R to extract this information. I leave it to you to determine that. And the third one is this. I want you to show for 2015 to 2024. You will see I did not include 2010 to 2014, but rather from 2015 to 2024, I want a table with four columns, the year, the population value, the year over year absolute change, and the year over year percentage change only. So how would you do that? There is a single line of code. Again, all these different exercises involves only a single line of code. It's just about being independent and trying to learn how to do things on your own. All right. Obviously, I will give you the solution later. I'm not going to give it to you now. I'll give you some time to do it, and then I will give you the solution by the end of this week. If I forget to give you the solution, the class rep will remind me accordingly, and I will give you the solution. So that's all with regards to the API. That's the first part of our lecture. The second part, the next part of our lecture will come later. I will try my best to send it to you by tomorrow, and if not, at least by the end of this week, you should obtain your videos. So that's the first part.